This is problem number 21 from section 7.2. Let's start by graphing these two curves and then figuring out the area that's stuck between them. Let's start with this one, but before I graph this, what I want to do is I want to graph just x squared minus 4. If I do that, x squared minus 4, I start here down at negative 4, and it's a parabola that goes up. I do that because that means that the absolute value of x squared minus 4, this area here where the curve is negative, is going to get flipped. So here's where it crosses at 2. Here's the x-axis, or the y-axis. Here's where it crosses at negative 2, positive 2. And what we have is a parabola goes down, it flips up to 4, comes back down to 2, and then flips up again. So there's the curve of the absolute value of x squared minus 4. This is a parabola that opens upward, and it opens upward, and the lowest it ever goes is 4. So it looks something like this. Parabola opens upward and crosses that other shape. Let me draw them separately so you can see. Second curve's in black, first curve's in red. There we go. We're going to need to know where that intersection happens, and that intersection happens when x squared minus 4 is equal to x squared over 2 plus 4. If I subtract x squared over 2 from both sides, I get x squared over 2. If I add 4 to both sides, I get 8. If I multiply both sides by 2, I get x squared is equal to 16, or x is equal to plus or minus 4. So the intersections here happen when x is negative 4 and x is positive 4. And what we have, we see a lot of symmetry. So I'm going to declare the area for this, for these regions in between the two curves as being twice the integral from 0 to 4. Actually, I'm going to stop there because I got that absolute value sign flipping this curve up. I'm actually going to go from 0 to 2, and the upper curve is x squared over 2 plus 4. And the bottom curve is not x squared minus 4, but the opposite is the part that had to flip. So minus the opposite of x squared minus 4 dx. All right? So that handles this area there. And now we have to write an integral expression to handle that area here. And that's going to be the integral from 2 to 4 of x squared over 2 plus 4 minus, and in this case, this portion of the curve was not flipped around. So it's just minus x squared minus 4 dx. There we go. The expression from here to there all being multiplied by 2 to exploit the symmetries. So let's clean this up and see what we can get. 2 times quantity, integral from 0 to 2. Let's distribute this negative sign through those two things, and we get an x squared over 2 plus an x squared is a 3 halves x squared. A 4 plus a 4 is something's wrong here. Something's wrong here. Oh, I wrote this down. No. Oh, okay. Let me go back here. I just made a little typographical error here. So this is minus x squared minus 4x. Okay? Since we're flipping it, we're taking the opposite of this whole expression. Of course, because this is the lower curve, we're subtracting it. So we end up knocking out those two. This indeed, those two add up to 3 halves x. These two will knock themselves out. So I don't end up with an 8. I end up with a 4 minus 4, which is 0. So there we go. There's our first expression. Plus the integral from 2 to 4 And let's say this is, let's start here. Plus 4 minus a minus 4 is an 8. And then I've got a negative x squared here, and I've got a x squared over 2 there, which gives me a net negative x squared over 2 dx. There we go. Now let's do some antiderivatives. Continuing on down here, still got the 2 out in front. The antiderivative of that term is going to be 3/2 times 1/3 x cubed evaluated from 0 to 2 plus 8x minus 1/2 times 1/3 x cubed evaluated from 2 to 4. See, if we evaluate these expressions on their bounds, oh, let's get rid of those 3's. I get 1/2 times 2 cubed minus 0 cubed plus 8 times 4 minus 1/6 times 4 cubed is 64. So there's the upper bound minus my lower bound, 8 times 2 minus 1/6 times 2 cubed, which is 8. Okay, that one closes there, one more to close there, and one more to close that one. What a mess, but we can do it. Here we go. 2 times. Doing this here, we've got 1/2 of 8, which is 4, plus, here we've got 32. Here we've got negative 64 over 6. Here we've got a negative 16, and the negative and the negative there make a positive 8, 6 to finish it off. Combining the units, I got 4 plus 32 is 36 minus 16. That's going to be 20. Here, I've got negative 64 and a positive 8. That's going to give me a negative 56 sixths. If I distribute my 2 through right now, I'm going to end up with 40 minus 56 thirds. Which means a common denominator of 3, so 120 thirds minus 56 thirds gives me a total of 64 thirds. And that's problem number 21.